I chose this graphic primarily because we have JavaScript today. It's only getting, I chose this because we have JavaScript today, we have planes, but the NASA X-plane, it is the future. Async await is in our future. JavaScript as a programming language is very elegant. It's not perfect, but it's the most popular programming language in the world. You can't really go to a website today without JavaScript on it. It has grown in popularity from its initial inception, which I think was in 1994, and it's still heavily used today. JavaScript is not perfect, though. It was built more as a scripting language and to do really simple animations on page, simple interaction. And then as applications started to grow, it became difficult to debug and maintain. I couldn't imagine developing websites in the 90s without the awesome developer tools we have today. One of the biggest things I've had to debug is callbacks. When you have callbacks and callbacks and callbacks, that is a feature of JavaScript. When it's misused, or as things grew in complexity, you had a callback and a callback and a callback, and you just have this cesspool of code that is very difficult to maintain and debug. If you're not familiar with callbacks, this is a helper function right here called doRandomWork, and this callback is a function you pass in. So you have a function called doRandomWork, and then this is a function. Some syntactical sugar in new versions of JavaScript, you don't need to include function, but you just have this nesting of nesting and nesting. It's very hard to look at that and figure out what it's doing. A wrapper for that came promises. So a promise is just deferred work. It's something that you'll do later. It's a promise. You're making multiple GET requests, but you're still passing a callback in to the .then says after you get the current user, then find their friends, then find their location, events, etc. So it makes it a little bit flatter. The future is async. Async, all it does is make asynchronous code look synchronous. Asynchronous code, you can think of that as go do something. I don't care how long it takes you, but free up my resources and then let me know when you're done. So all async functions do are return a promise. So you can see right here is I just made this function return a promise. So this set timeout is basically thread, sleep, run, whatever. And it's just going to wait for some random amount of time, less than a second. The important thing here is that this is wrapped in a promise. So now when I say do work and I throw the async keyword in front of this function, I can now say await, 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 and it just makes it look flatter. It's a little bit more straightforward to follow that I'm saying do some random work, code and beer, and then return it. I'm still calling this promise and logging it there, but it's a little bit easier to reason about. When I talk about reasoning about code, you're just making it look synchronous. You don't have all this extra tabbing and spacing and brackets. It's very easy to look at it, glance at it, and know X, Y, and Z. This is what my code. You got to look at your code and make sure that what you think it's doing, it's actually doing. There's some problems here, though. We're doing this serially. So we say async function await, it holds on. Await, holds on. Await, holds on, and then we do it. So that is happening sequentially. Where this is important is what if you just say, go do all these things and let me know. Things happening in serial, if this task takes 1, 2, 3, total time is 6 seconds right here. If you do things in parallel, you get the max 3 seconds. This is the limiting factor right here. This is the entire limiting factor. So this takes 6 seconds. This only takes 3. Why is this important? It's because you have to write your code differently. What you can do is have an asynchronous function. Instead of putting await 3 times, so it doesn't have to hold after each statement is done, you can wrap it in this. If you want to call it static, you can call it promise.static. You just wrap all your deferreds or promises in an array, and it will return an array with all your results in it. Where things get a little bit tricky and it's advanced, you can look into it if you want to, is what happens if you make 3 asynchronous casts and one of them fail. Well, by nature, you don't have to wrap promises in a try-catch because there's a catch block for it. So you don't have to do that. It's just part of a layer of abstraction. The most important thing is always remember, if you're getting into this code, is that everything is basically a promise. Every async function, you want to return a promise. If you don't return a promise, your value will be wrapped in a promise behind the scenes. As you saw, you're going to have to refactor a bunch of code. If you try to take what your current existing code and try to make it work, you're going to add an async keyword in front of that function, and that kind of just travels up the chain. Every function that you make asynchronous, everything that calls it needs to add async as well too. There's some caveats for it. If you're not doing async and await right now in JavaScript, that's fine because it's going to be in ECMAScript 7 standard. But you should start considering it because it's easier to write, reason about, and as well as we're competing with the Russians. So you can see the trend over time for async and await on Google Trends is just getting more and more popular. So if you're not searching async and await, you should look into it. What's worse is the Russians are writing better code than us because their code, the Russians are writing asynchronous code. So while they're writing code that takes 3 seconds, we may be writing code that takes 6 seconds. So by the time they attack us, we've already been compromised before we can react. Async and await, I think, came out in .NET 4.5. Nick Martin would probably know. I don't know. It came out recently. But async and await, those keywords in the language, I was most familiar with them from a C# background. This is like the de facto chart I've looked at many times. This is from MSDN explaining how async and await works in C#. I kind of put this on there as a joke because you're not going to understand that in 20 seconds. But there's an MSDN article explaining the flow. The first time you read it, you won't get it. Read it a couple times. How does it compare to C# though? They're extremely similar. Async, JavaScript's loose. C# says add async at the end of the method to indicate it's async. Like everything, like for threading, JavaScript only has 1 thread. C# you can have many threads, but async doesn't block your threads. So in the end, it doesn't even matter as long as your code works. Cool.